So this is problem number 2 from Physics 2212 Modern, Greco. And we're trying to find the electric field caused by these two dipoles on positions A, B, C, D, and E. And so let's find the position, let's find the dipole, let's find the electric field on position A. So first this goes to the right, and this goes to the right again. And this electric field is going to point to the right, but it's not going to be greater than position B right here, because this is exactly on the dipole, and therefore it's going to create a stronger horizontal component of the electric field. So this will point to the right here, and this will also point to the right here. And the net electric field at C will be 0 because the charges on these two this dipole and this dipole is the opposite, which means that the electric fields will be going the opposite way in the same magnitude. So this net electric field will be 0, and because and the electric field for position D will go to the left because of this arrow right here, and because this is and position D is exactly in the dipole, it means that only the it'll be strongest. Position D will have the strongest horizontal component, as with the same with position B right here, and position E will also go to the left, but this is also, position E is also affected by position B's, the dipole on position B, so it'll go less to the left, the electric field. And so off to problem number 2, and we need to calculate the electric field, net electric field at the center of the bottom dipole, which is in position D. So what I did electric field of the top, so this is the dipole on the top. This is the electric field on the bottom dipole affected by the top dipole. So I knew that because this is perpendicular to each other, the dipole, I knew that it would be 1 over 4 pi epsilon naught times q over r cubed, and the distance itself is d right here, so it's 2d. Right here, and it's going to the sorry, I made a mistake. And so this will be going to the x direction, plus x direction, because this is attracting to the right. So it would be simplified epsilon naught times qs over 8d cubed, and and this is and we have to calculate, there's an electric field coming from this this point charge and this point charge. So if we just split the dipole up and treat it as 2 point charges, and this will both all go, the electric field will all both go in the negative x direction, because this has a negative charge and this has a positive r hat, and this has a negative r hat and a positive charge, so it'll both end up going to the left, and which is why the total electric field will go to the left, because B is much closer than B is much farther than the center from right here compared. So it's 1 over 4 pi epsilon naught times negative q over s divided by 2 times that by 1, 0, 0, which can also simplify to x hat. And this is the negative charge, and this is the positive charge right here, e to the 1 over 4 pi epsilon naught times q over s over 2 squared times up the r hat, but which is a negative x hat, which can be represented like right here. And so if we simplify that out, it would be we would have to add these two together, and it would end up becoming negative 2q pi epsilon naught times up by right here. This is the solution for the electric field caused by these 2 point charges. So what we need to add up is this, the electric field at the top on the bottom, and this is the electric field caused by the point charges on the bottom dipole. So if we add these together, E net equals E
top plus E negative plus E positive charges. This is point charges right here. I'm referring to these. And it would become 1q over 4 pi epsilon naught times s over 8d cubed minus 8 s squared to the negative x direction right here. And this will simplify down to yes. So determine the direction of the net force on the top dipole. So the direction of the net force will go on the negative y direction towards the bottom dipole, because the two poles are in the opposite orientation, so the repulsive forces between them, proton and proton A, proton B, will not fully counterattack the attractive forces as they are acting at an angle.